So for today, by the end of the hour, I hope that you'll know several probability terms. And there's some words that you'll have to know for probability. And they'll ask you this word on the test, and I'm not going to tell you what it means. You got to know what they mean. Experimental versus theoretical probability sounds super scary. It's actually super easy. I'm going to explain that one right now. If I have a coin and I say that the probability of getting a heads is 0.5, does that make sense to you? Okay. Now, what if I actually took the coin and I flipped it a whole bunch of times? Like, we're talking a lot of times. Like, if I flipped it 1,000 times and only 250 of them were heads, would you be suspicious there was something weird about the coin? 250 out of 1,000? You should be suspicious, because when you get a lot of flips like that, that's called the law of large numbers. Now, would you agree that if I flip it 3 times, there's no way it's going to come up 50% heads? Out of 3 flips? There's no way to do that. So if it's a small number, you can't really count on that you've done enough for the experiment. So, for example, if I take this die right here, I have just a second, please. And I roll this die. What is the probability that I get a 6? I would like you to write it down. And use a calculator, because we're usually going to get decimal answers. What's the probability that I'm going to roll a 6? All right. Did you know that there's 1 out of 6, so therefore it's, well, you divide them, and this is one of the ones that's really bad because it makes kids think that this is how probabilities work, fractions work. 1/6 is a terrible one to show a young kid, because then they're like, oh, so it's just like 2/3 is going to be 0.23. You know what I mean? No, that's not how that works. Okay, but 0.16 is probably what you got when you divided them on your calculator, right? Okay, so that's theoretical. I didn't actually do an experiment. So here's a die. I'm going to roll it. And I would like you, just so that I don't get like you don't think I'm biased in reading you false numbers. I'm going to do it a bunch of times, and we're going to keep track. On your iPad, I want you to keep track of what numbers I got. Okay, here's the first roll. Say it loud.
6.
What is the 6? 2
6.
6s.
6.
3 6s.
6.
4 6s.
6.
5 6s.
6.
Are you suspicious yet?
Yeah.
You should be. Now, the weird thing is...
2.
Ooh, 2.
6. 2.
All right. Only 2s and 6s, then you should be suspicious that there's something wrong with this die. And there is. Would you please tell them how many 6s do you see on it?
3 6s.
3 6s. And then how many 2s do you see on it?
3.
3 2s. That is a dice that's set up to cheat. Okay, so I want you to think, what do you think the other die that came with it has on it? If this has 6s and 2s, what do you think the other die has?
3s and
5s
and 1.
and 1s. Because do you get that you're going to get 7 a lot that way? With a 5 and a 2? And a 6 and a 1? See what I'm saying? All right. So it's kind of the cheat dice that can make it come up 7 a lot. But yet, it isn't super obvious, because not many people will check all the sides of the die. So if I actually did an experiment right there, I could realize that my theoretical probability was crap. And when I actually did it, I did an experiment. How many 6s did I get? Somebody added them up. How many 6s did we actually get? Do we have 6 sixes? Out of how many rolls? Then the probability of getting a 6 was actually 6 out of 8. Now, if I rolled it enough times, we actually got a ludicrous number of 6s. There should have come up 2 just as much as it came up 6. There was 3 2s and there was 3 6s, but 6 was on a roll there. Okay, so that's the difference. Experimental probability, you do an experiment and you keep track. Theoretical, that's mostly what we do in here. Mostly what we do is we assume, oh, there's 6 numbers on it, 1 in 6 chance. Okay, all right, now you know theoretical versus experimental. Now, how about how to find probability with contingency tables? Well, if I give you a table, here's a nice simple one. We're going to have righties and lefties and cat people and dog people. Now, you probably didn't pick the pets that you live with. Your parents probably did. Maybe you did. I don't know. It could be some of you. So I'm not sure that there's going to be any kind of a correlation with you being left-handed and you having a dog or you having a cat, because you didn't actually pick the animal that you probably live with. Now, we need one more, and that's what if you have both, cats and dogs, okay? Or we could even have another one where you're ambidextrous, which means you use left or right hand equally. There's very few, but there's a few ambidextrous people out there. But for today, why don't we just say if you have a cat and a dog, you're going to go in with the cat people, because there's not going to be as many cat people anyway. All right, so if you're like, but I have a cat and a dog, we're going to count you as a cat person. All right, so would you please raise your hand if you are a right-handed cat person? 1, 2, 3, 4, 5, 6. There's 6 people that are right-handed cat people. So write this down. All right. Next thing is, who are the left-handed cat people? And again, if you have both a cat and a dog, then you're a cat person. 0. Okay. Who in here is a right-handed dog person? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That doesn't leave many left for left-handed people. So, yeah, this could have been a flaw. Maybe there's nobody left-handed in here. Or the left-handed person might not have a dog or a cat. That's another possibility. Is there any lefties in here? I should have started with that. Okay, this is not a great system. All right. Erase the numbers on the inside, and we're going to change it from righty and lefty to your hair is what you would call dark or light, and you have to decide that. Maybe you've dyed your hair. Maybe yours is right in between, and you'll have to make the call. Do you think you're dark-haired or light-haired? You decide. I wasn't going to go with black, but even there, some people have black hair, but they're like, no, it's brown. Okay, I don't want to argue with you. Light-haired or dark-haired? All right, so we're going to go with light or dark-haired. And if you have no hair, you're going to count as light-haired. Okay, so who are the light-haired cat people? Raise your hand if you have light hair and have a cat. Oh my gosh, nobody? Oh, okay, fine. We're not doing light hair and dark hair. Let's see. Shoes. White shoes or not white? All right, and if they're mostly white, they're white. Okay. All right. Who in here is a white-shoed cat person? Oh, now we're getting some numbers. 1, 2, 3. All right. Who in here is a white-shoed dog person? 1, 2, 3, 4, 5, 6. Wait, keep them up high. 1, 2, 3, 4, 5, 6, 7. Who is a not white-shoed cat person? 1, 2, 3. Who is a not white-shoed dog person? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome.
Yes.
Now, we're going to actually add up around the edges. 3 plus 3 is 6. 7 plus 12 is 19. 19 and 6 makes 25. 3 and the 12 makes 15, and 7 and 3 is 10. And see how that has some symmetry to it? The 9 and the 16 add up to 25, and the 10 and the 15 add up to 25. This is what's called a contingency table. Okay? The contingencies are contingent on this, like your dad might say, contingent on you having your homework done. Then I'm going to give you, I don't know, a chance to drive the Cybertruck today or whatever it is that you're going to do. Contingent on. All right. So contingent tables have a whole bunch of possibilities. I'll give you an example. What is the probability that I pick one of you and you are a cat person? It's a fraction, which eventually you'll divide. For right now, I will save you the time. Just what's the fraction? All right, cat people is 6 out of a total of 25. 6 out of 25. Now, will the answers always be out of 25 for this? No. A lot of the answers are, but it won't always be out of 25. All right, for the next question or two, maybe it'll be out of 25, but you'll see all of a sudden it won't be out of 25 anymore when they get complicated. All right, how about this one? What's the probability I pick a random person and they have white shoes? – 10 out of 25 is correct. Then why would it ever not be out of 25? Can anybody make up a question where the probability answer is kind of like, the questions are kind of like what I was just doing, except the answer would not be out of 25? Yes?
What's the probability that you pick a dog person and they have white shoes?
All right. That's exactly right. So I'm going to repeat that in a slightly different way. What's the probability that I only ask dog people and the person I get has white shoes? All right, that's called a given. So I'm going to say it differently with the word given. Given dog, as in it's only going to be a dog person. Then what's the probability of white shoes? That's how it would probably be written on your test. Given dog, what's the probability of W, which you'd have to say is like clearly not it's not W, it's W. So given dog meant I'm only going to look at these. I think like circling that really helps you understand, oh, so it's only out of 19 then, see? Now what's the probability of W? If you can only pick those, you're not going to say 10. There's not 10 white-shoed people. There's 7. 7 out of 19. Who had 7 out of 19? Okay, cool. All right. Now I'm going to give you one more without any guidance. Just see if you can answer this question. Given the people that I like bring out into the hallway only have white shoes, what's the probability that if I pick a random one that they'll have a cat? Given that they will have white shoes, what's the probability of cat? Please talk to the kid not behind you, but next to you, straight across these two rows. See if you got the same answers. You talk to the same person behind you. So as soon as I said given W, it was out of 10. I want you to listen to this part. Given changes the denominator. As soon as I said given, it became out of 10. See how that changes the denominator? All right. So givens change what it's out of. All right. Given white, it had to be that. White shoes this was. And given No, not given. Now I want a probability that it's a cat person, 3 out of 10. Are you getting this? Cool. Then I'm almost done. Now we'll go back into the notes. So some vocab. Random. If I say it's random, you tell me if this is random or not. I throw my pen out there and it rolls underneath somebody's desk. Would this be truly random if I do it right now like this?
No.
No, because I could steer the pen. I could make it go in a certain direction. Even if I turn around backwards, is it more random if I turn around backwards?
Yeah.
Yeah. Is it truly random? No, because I can kind of direct it. I can make sure that Brandon doesn't get it, because he'd never return it. Okay. Or would this be random? I taped a $100 bill underneath somebody's desk. No, I actually didn't. But if I did, would it be random?
No.
No, because I have a seating chart. I know who's going to be sitting there. There's a lot of times where people think things are random and they're not at all. I did a poll outside of the ice cream place and asked them, which flavor did you pick? Would that be random?
No.
I think it is. Now, if I asked them if they liked ice cream, would that be random? No, because I had a group of people that like ice cream. They're there because they like ice cream, right? There would be a biased group. It wouldn't be random. But if I asked them which flavor did you order, then I'm probably getting a random sample. So it's complicated on being random or not. All right. So, bottom line is it says no individual outcome is predictable. It can't be predictable. You can't tell ahead of time. All right. So, it's very hard to be random. That's one of the biggest problems with polls. If you ask a group of people, what's your opinion on this? Usually people are in groups, which then makes it not random. If I ask all of you, do you like Minnesota? Well, okay. You just say no to everything. But there's a group of kids that will just say no to anything, and they're not a random group either. Okay, so my point is, you guys live in Minnesota. You're biased just by that. But if I asked you, what number is better, 1 or 2? Don't say it. Write it on your iPad. What number is better, 1 or 2? Could you guys be a random group when it comes to that question? I think so. I don't think you're biased. Okay. All right. I'm curious. How many picked 1? Raise your hand if you picked 1. Who picked 2? Raise your hand if you picked 2. So that's almost 50-50. All right, cool. Okay. So things that are random, we consider rolling a die random. Now, if it's a cheat dice, obviously that's going to change your probability, but it was still random whether a 6 or a 2 was going to come up. It was just a probability of 50-50 or 0.5 of each, because I had a cheat die that's only got 6s and 2s. All right. Drawing a card from a deck, that's considered random. And again, there's ways to cheat that. You could have a deck where you've marked the cards and you've like put a little fold in the corner of an important card like the ace or whatever, and then you're cheating, and that's going to throw off the randomness. Flipping a coin is considered random. All right. Now, when they say the event, that's just you're going to do something like flip a coin. That's an event. All right, moving on. A lot of people get confused about rolling dice, and they think that all the numbers from 2 dice that are added together are equally likely, and they aren't. That's weird, isn't it? If you roll 1 die, I'm going to grab a normal die now. This one's got the numbers 1 through 6 on it. It's a normal die. Then, if I roll this, there is a random chance that any number could come up. But as soon as I roll 2 dice and I add them together, it's not random anymore. I mean, it's a random event, but the probability of it coming up is way higher on 7. Look at all the ways you can make a 7. That's why when you play the game Craps in Las Vegas, they make 7 one of the numbers where it's, like everybody knows that 7's like a lucky number, but they also didn't want to make it so every time you roll the 7, you win. It's going to roll too much. You're going to win too much. So on the game of craps, when you roll the dice, it's called you're coming out. You roll the dice, and if you get a 7, at that moment, you do win. What is the probability of that? Stop. Look up here. Figure out the probability that you're going to roll a 7. When you roll on your first roll, when they hand you the dice, and you roll for the first time, if you get a 7, you win. Well, what is probability? I'm going to keep coming back to this. Leo, I don't think you're with me. Am I wrong? You're with me?
Yeah.
Awesome. You're on the same page? Good. Okay. I'm going to keep coming back to what probability is. Probability is what you want over what's possible. Now, that is shortened up a lot, but I feel like those are a really valuable definition for you to write down because our probabilities are going to get complicated. And I'm going to keep coming back to that. It's what you want over all the things that are possible. Do you get from looking at this chart that there are 36 things that are possible when you roll 2 dice? Look at it. That's one of the 36 things that could happen when you roll the dice. It actually adds up to 36 different things. If you counted all of these, and all of these, and all of these, and all of those, if you add them all up, there's 36. So what you want here is you want to get a 7. So how many of them are there? How many ways were there to get a 7? 6 ways. That's what you want over what's possible is 36. Does it reduce? Sure. But 6 over 36 is a good way to say it so you can see how I got it. There were 6 ways to get a 7 out of 36. That is a 1 in 6 chance. And we already did this one earlier. It's a 0.16 probability. Do you agree that's a pretty low probability? And yet, you're more likely to roll a 7 than anything else. What's your probability of rolling snake eyes? That's that one. 1 out of 36. That means if you roll the dice a whole bunch of times and you finally get a snake eyes, there was only a 1 in 36 chance of that. So if you roll the dice a lot, you can't say every time you've rolled it 36 times, you're for sure going to have gotten snake eyes or a 1-1. Total of 2. You can't say that. I roll at 36, that doesn't guarantee it. But out of 36 rolls, on average, one of them should be snake eyes and one of them should be a 12. You guys know what the name for that one is? Boxcars. 6 and 6, they kind of look like train cars, then they're called boxcars. Anyways, this is called snake eyes, this is called boxcars. I got to stop doing this or people are going to be like, Mr. Server's teaching me how to gamble. No. I'm just trying to use a real world example. All right, so now I'd like you to figure out this. If you were playing a game with a little kid who did not understand the dice, and you said, let's play a game. Whenever 2 or 3 or 11 or 12 come up, you win. So Jimmy, you're playing with Jimmy, and he's little, and so he doesn't know any better, and you say you get the numbers 2, and then whenever a 3 comes up, total of 2, total of 3, total of 11, or total of 12, you're going to win. And you only win if you get a 7. Do you get how Jimmy's going to think that he's more likely to win than you? I want you to figure out who is actually more likely to win. Jimmy wins if he rolls a 2 or a 3 or an 11 or a 12. Total. It's a trick question, isn't it? You're equally likely to win. See what I mean? Even though they've got 4 numbers and you only have 1, you're equally likely to win. Your probability of winning is 6, because there's 6 ways that this could happen. 1 way, 2 ways, 3 ways, 4, 5, 6. 6 ways out of 36. And you have 6 out of 36 from that. Okay. A deck of cards. If we ever ask you a deck of cards question, we will include this list of what all the cards are. because we are fully aware that some kids don't play cards, and you don't have any idea how many aces there are in a deck of cards. Others of you play cards a lot. How many of you would say, I'm really familiar with cards? Raise your hand if you're really familiar with cards. That's only half of you. All right. So I play cards, and so I would be like, well, yeah, there's 4 kings, of course. But if we ever do a question about cards, we'll have to give you this. All right. So given this, given that out of the corner of my eye, as the cards were being dealt, I saw that your card that you got dealt was red. Given that I saw it was red, what's the probability that it's the red 7? Given that it was red, I could see that it was red. Just got a flash of it. What's the probability it was a red 7? To keep you from having to add all these up, there's 13 of each kind. So then all the red cards total would be what? 26. So what's the probability then that the card I saw flashed was a red 7? I'm going to start with not reduced.
2 out of 26.
2 out of 26, which does reduce to 1 in 13. Raise your hand if you understood that. Okay, good. One more like that. You by accident give up the fact that your card's a club. Like from something you said to the kid next to you, I can tell you got a club. What's the probability it's the 8 of clubs? Because there's only one 8 out of 13. So it's 1 out of 13. Make sense? All right. And I'm using the word given a lot because I didn't want it to be out of 52. But what if I don't say given? You have a card in front of you. I don't know what it is. What's the probability? It's the ace of spades. If you don't know what a spade is, it's that one right there. What's the probability that that card in front of you was the ace of spades? Wasn't there only one of them? And how many cards are there total? 52. 1 out of 52. All right. On to the next slide. So the probability is the measure of the likelihood that an event will occur. Don't have to memorize that. But what if I only left you with one thing today? Probability is what you want out of all the things possible. And like on that card question, wasn't every card possible? Kind of, unless I said, I know it was red. Then not every card was possible. And I changed what was possible by saying, given it was red, then we change what's possible, see? All right, and this is that 0 to 1 thing, which we already talked about. On to the next page. Experimental, that's where you actually do it a whole bunch of times and you see what happens. Like our 6 example. Kept getting 6 over and over and over again. Turned out it was a cheat die. Theoretical is what we mostly do, where we say like there's 6 things on a die, so then there's a 1 in 6 chance. All right, moving on. This is one where we've got the righties and the lefties and the freshmen and the sophomores. Okay, we could have done that, but I chose to do like cat people and white shoes. All right, let's move on to this one. This one's where you're starting to ask some givens, and I want to see if on this page with the kind of like orangey colored writing at the top, would you please try to answer those 6 questions? And leave them as fractions for now to save you time. On a test, they would be decimals, but for now, just write them as fractions. And we're pretty much done. Would you please compare your answers with 1 through 5 with the kid next? All right. What's the probability that they were left-handed? Then that would be 13 out of 100. Why did I pick out of 100? Because it didn't give me any given. Go for the biggest number that they have. 13 out of 100. Probability that they were a sophomore. Well, that would be 48 out of 100. Given that they're a freshman, okay, so then I'm going to circle this, and my only things I can pick are in there. Given that they're a freshman, then it's out of 52. And then what did I want? I wanted a person who was right-handed, and that was 43. What I want out of what was possible. And given that they're lefty, I'm going to circle this area in red. So then it's out of 13. I know that already. As soon as they tell me given, I know they changed the denominator. Probability that they're a sophomore, that would be 4. And I bet you the last one's the only one you weren't sure what to do. All right. I want you to write this down. Or means add. That is oversimplifying, but it's usually true. Or means you're going to add them. So, find all the right-handed people. Well, these are all the right-handed people. I'm not going to do the total. And find all the freshmen. It's this and this and this. So or means you add them up. So that's going to be 87, 96. Raise your hand if you had 96. Good guess. You were right. Out of 100. Or add. Like, I'll give you an example. What if I said, you win if you have white shoes? Okay, now I got a certain number of people I won. You win if you have white shoes or you have glasses. You got to just added a small group of people that didn't have white shoes, but they had glasses, and all of a sudden now I have more. It's like or means add. Okay. All right, you've made it. How about and? Let me make it. I'll use the example again. You win if you have white shoes, and you have a piano. Do you get that got smaller then? You have to have white shoes and a piano. So that gets to be a smaller answer. So try to remember this also. Ors are big answers. Ors are big answers. It seems opposite. But if you win, if you have white shoes or a cat or a dog, or you go to school, well, that just pretty much all of a sudden made it a huge answer. Or is big answers. And are small. You have to have white shoes and a piano and a lemur. Now it's really small. And are small answers. That'll help guide you. All right. So I'd like to actually get to the homework. Homework is a worksheet I've picked out. Unfortunately, it's longish, but each problem is so simple that it won't be that bad. Here are the only ones I think are repetitious so we can cross them off. And that's always delicious. The repetitious ones were 6 and 13 and 14. Cross those off. There is an answer key to help make sure you're doing it right. And remember that today, when you get your test back, your cumulative test, it is not in the grade. So don't go run back and look at your grade. You don't know what's going to do to your grade yet. Obviously, if it's higher than your average right now, yay, your grade's going up. it's lower than your average right now, it's probably gonna hurt your grade a little bit. There's a few people that happen. Most of you did pretty normal, about what you did before. A few of you did better. And again, I will ask to hand those back to you now, and then at the door when you walk out, I will take them back from everyone. So if you don't get one back, you should tell me, because at the door I'll be demanding that everybody give me your test back. So if you don't get one, you should come up and talk to me about that right away. All right, and that's all I got for the video for today.